What is a z-test in statistics? When do we perform a z-test? And what is the difference between a z-test and a t-test? In this video, we will try to understand that. Let's say the mean score of students in a school is 75 with a standard deviation of 10. A teacher claims that the mean score of the 40 students in his class is significantly higher than the mean score of the students at the school. Now, the mean score of the students in the teacher's class is 80. Our question is the mean score of the students of the teacher's class significantly different from the mean score of the school? To know that, we can perform a one-sample z-test. A z-test is a hypothesis test that is performed when the standard deviation of the population is known and the test statistic under the null hypothesis can be approximated by a normal distribution. A z-test can also be performed if the sample size is sufficiently large, usually more than or equal to 30. As we know, as per the central limit theorem, if we take random samples of sufficiently large sample size, then the sampling distribution of the sample means will approach a normal distribution, and this will hold true even if the population is not normally distributed. So, let's look back at our example. We can state two hypotheses here. The null hypothesis is that the mean score of students in the teacher's class is not significantly different from the mean score of the students at the school. In other words, mu is equal to mu0, where mu is the mean score of the sample and mu0 is the mean score of the population. And the alternative hypothesis is that the mean score of the students of the teacher's class is significantly different from the mean score of the students at the school. In other words, mu is not equal to mu0, where mu is the mean score of the sample and mu0 is the mean score of the population. And let's say our significance level is 0.05. So, now we can calculate the z-score based on the information we have. Here, the sample size n is equal to 40. The standard deviation of the population is sigma is equal to 10. The mean score of the sample is mu is equal to 80 and the mean score of the population is equal to mu0 is equal to 75. At this point, we can go ahead and calculate the test statistic. The z-score can be calculated using the following formula. Z is equal to x bar minus mu0 divided by sigma by root n. Here, x bar is the mean score of the sample, that is equal to mu is equal to 80. So, if we put all the values, we get z-score is equal to 3.16 after calculation. Now, we can look at the z-table to find out the p-value corresponding to the z-score. Please note that there are two z-tables, one for positive z-scores and one for negative z-scores. In our case, the z-score is positive. So, we will look at the positive z-score table. Here is the positive z-score table. And we need to find out the p-value corresponding to the z-score of 3.16. To do so, we will first look at row 3.1 and column 0.06. We get the number 0.9992. That means the area on the left side of our z-score is 0.9992. So, the area on the right side of our z-score is 1 minus 0.9992. That is 0.0008. Now, this is a two-tailed z-test. So, we need to find out the area on the left side of the z-score minus 3.16 also. And as the curve is symmetrical, the area on the left side of z-score of minus 3.16 will be 0.0008. Summing the values up, we get 0.0008 plus 0.0008, that is 0.0016. This is our p-value. Our significance level alpha is equal to 0.05 and the obtained p-value is less than the significance level. Hence, we reject the null hypothesis. So, we can conclude that the mean score of the students in the teacher's class is significantly different from the mean score of the school. So, when should we perform a z-test? What is the difference between a z-test and a t-test? We can perform a z-test when the standard deviation of the population is known and the test statistic under the null hypothesis can be approximated by a normal distribution, or the sample size is large, usually more than or equal to 30. On the other hand, if the population standard deviation is not known and the sample size is small, usually less than 30, then we can perform a t-test. We are going to discuss t-test in detail in our next video. Interested viewers may find the relevant link in the description. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.